Let's get started as people continue to join us. And I want to say welcome to the second of our planned series of at least 3 virtual symposia on careers in data science and statistics, co-sponsored by the Nevada chapter of the American Statistical Association and the University of Nevada, Reno Department of Mathematics and Statistics. My name is Chris Tong, president of the NVASA, and joining me hosting the Zoom session is Professor Mihei An. And today's session is being recorded, so I hope that doesn't inhibit anyone from asking a question, but if it does, you can type the question into the chat and Professor An or I will ask it on your behalf. And I'd like to introduce our speaker. Lissa Callahan is a data analyst with ADM Associates and the University of Nevada, Reno Department of Mathematics and Statistics. And I will ask her to introduce her colleagues who will be joining us for the panel discussion. So with that, Lissa, it's all yours.
Okay, thanks, Chris. My name is Lissa. Like you said, I graduated from UNR about 2 years ago, the spring of 2019, and I started at ADM shortly after that. I met some colleagues there at the career fair, not the STEM one. I think it was the general career fair. So I've been here for a couple of years. ADM is a consulting company. We analyze energy. We do energy usage research, and we verify savings for different energy saving programs for various utility companies in the U.S. So I'm joined here by my coworker and boss, Alex Horn, and then Justin Merkel and Chris McBride, who are all data scientists at ADM and work with me at ADM as data scientists. I don't know if you guys want to do a brief introduction for yourself, or I can, yeah,
sure.
Trip through that.
Lissa, yeah, so I'm Alex. I've been working with ADM for almost 3 years now. I came to a data scientist in probably a non-traditional, or what would be considered non-traditional pathway in geological sciences from Arizona State University. And I left a career in geology with a focus on modeling to break out into a different type of resource, still looking at modeling, but in a context.
I can go next. My name is Chris McBride. I got my degree in physics and astronomy, and then decided to pursue data science. And I've been with ADM about 3 or 4 years. A lot of the focus of my work is actually deep learning, along with building other machine learning models that add value to our clients.
Can you guys hear me? Hello? Hey, my name is Justin Merkel. Okay. I also work at ADM. I have for almost 2 years now as a data scientist, mostly doing analysis on larger data sets. Before that, I worked at Dillard's as a data scientist, and then before that as a software engineer. So I sort of transitioned into the data science role. And so yeah, about 4-ish years total doing data science stuff, and a year and a half before that of software engineering. And I graduated before working at Dillard's with a degree in computer science. So, yep.
Cool. So I'm going to do a quick, sort of a quick example of something that the sort of analysis that I do a lot of at ADM. I work on mostly what we call behavioral modification programs, which means that like the way that we measure savings is essentially by measuring the difference in in people's energy consumption before and after treatment using their billing data, usually monthly billing data for in my case. So I also work on some like commercial and residential direct install type of programs where that has to do with, you know, if you install a particular type of light bulb that replaces a particular type of light bulb, there's a deemed measurable savings value for that, and you can calculate it, you know, using the quantity and the date that it was installed. But these behavioral type programs and a lot of the programs that we analyze have to do with this, you know, require some sort of a model to show the change. So measurable savings for this particular behavioral program is determined using a difference in differences model, such that we measure the difference between the energy usage over time. So I'm gonna share my screen and show you this. Okay. So I hope you guys can see this. Is the font big enough on this? I have this markdown
Yes.
file over here.
Yep.
Good. Okay. So yeah, I kind of already explained what we do at ADM. Please stop me if you guys have a question about the code or the terminology, or, you know, if I'm lagging and you want me to move it along, just give me a shout. But yeah, if you have any questions, let us know. Otherwise, Alex and Chris and Justin are, you know, waiting around for your questions afterwards as well. If you have general questions about, you know, working in data science or you know, their educational paths or anything else, feel free to ask. So just as a reference point, my data for this program show that most households in Northern Nevada use an average of about 23 kilowatt hours per day. So that's about 700 kilowatt hours per month. And then this is just a little picture of kind of what I mean by a difference in differences model. We're measuring the difference in this change here. So ideally we have a control and a treatment group that are well matched so that there is little difference between their usage trends prior to treatment intervention. And then if the program if it's a successful program and has large savings, we'll see a larger gap here after the intervention starts. You'd hope to see a larger gap between the control and treatments. Whereas you want your control group to represent what the treatment group would have done without intervention. So I'm going to load in some tamed, sort of slimmed down data set. These are fake account numbers here, but this is generally what my data looks like after I have cleaned it, and sort of it's about ready to go for my regression model already. But so here we have the unique identifier, our account number. The reading end date determines when that billing cycle was. So this is like for this particular person, this is their average daily consumption during the reading period that ended on June 8th, 2018. So this is before treatment started for the treatment group, which was May 2019. This particular person here at the top of the data set is a control group member. And then we calculate what we call a cooling degree day and a heating degree day, which has to do with the weather and the average number of days for which it's cool enough to need the heater on, and vice versa with the air conditioner. So that's a sort of a normalized term that we use to calculate savings. Am I making sense? Am I talking too fast?
You're great.
Okay. And then we can get our participant counts straight from this billing data. So we're going to start out with 5,000 potential control group members and almost 5,000 control group treatment group members. And we are going to match these control group members to the treatments because they are, while these are a set of participants that were set aside and not targeted for treatment, and they should be good, a good subset of what a control, someone who, hasn't engaged in any energy saving programs would look like. They're not necessarily chosen in relation to our treatment group members. So they're not necessarily well matched, not necessarily paired up well with our treatment group members. So, so we're gonna take those, and so we'll filter our billing data for only the pre-treatment data, because that's what we want them to be similar about. And then I have some, it's kind of long-winded, so I left it off of my markdown sheet here, but this create seasons function, I can show you over here if you want. I love markdown. Do you guys love markdown? I like it.
I use it every day.
Markdown for the win.
So here we're taking we take the pre-data, and we're going to create another term that is just more normalized in relation to those heating degree days and cooling degree days. But we're also splitting it up between summer usage, and then we're calling the rest of the year winter, because especially in warmer climates like Vegas and then in other states like Oklahoma, the electricity usage in the summer is cumbersome for the the energy grid and everything else. It's much higher than in the winter, since most people will use gas or some other source of energy to heat their home. So summertime is a high electricity consumption time. So we are going to do some stuff here. Let me know if you want me to explain any of this, but essentially just formatting it in different ways and calculating these other terms that I wanted to use, and then getting rid of any terms that are going to cause us to have NAs. So this is what we end up with. This is what our data set looks like with these two new terms. Click over here, right here, for our summer and winter value for each particular participant in the control and treatment group. So now that we have our seasons, we're actually going to run that matching function, which again is pretty long. So I have my code over here, but I can give you a little glimpse. Sorry about the scrolling. Okay. So I'm going to use a package called matching. Another common package I think that people use for matching controls and treatments is the Match It package, capital M, capital I. And in that package, I think it is usually more of one step. This is one that I've had success with this particular group, where you use the GLM, the general linear mixed model. You establish that before you run the matching function. And so we are, relating the treatment group members to that summer and that winter term that we established. As binomial, they're either treatment or they're control. It's not, this GLM function will default to a normal distribution. So for our match function, we're going to set the replace argument to true, meaning that we are going to replace our control group members back into the pool. So, so that if there is a control group member that is well matched to two different treatment group members, we're going to utilize that in order to find the best matches. This will result in fewer unique control group members than treatment group members at the end. Whereas otherwise, if we had this set to false, we would have a one-to-one match. But that might cause us to lose some treatment group members that don't have good matches in the control group. And in addition, the order would matter. Whatever order our treatment group members started out in would be the ones at the top, in theory, might end up with better matches than those on the bottom because they have, the pick of the whole pool in order to be matched with, rather than just whatever is left when you get to the end. So so setting this argument, replace equals true, generally ends in better matches. And then ties is another potentially random element where you might randomly break ties. But if you just say false, then you won't end up with any ties at all anyway. And then some of this is mostly just it's formatting the way that it spits out. And I'll show you what that looks like over here. Sorry, this is what that looks like here. So we have this treatment group. This is the account number that was in a treatment group. We have that denoted by this 1, and their summer and winter usage. And this is the control group account that chose to be matched with that treatment group account. And here's their usage here. So you can see that it's pretty close. And we can grade our matches here. This is the output from the GLM model. And it shows that, so we have this column before matching and after matching. And so these are showing the mean treatment is very similar because I think we can check, but I think we only had 2 treatment participants that didn't find a match within our constraints. So our average treatment for the before and after matching is the same, but our control is slightly different. It's closer to the average usage for the treatment group. So that's good. So these are the sort of things that I like to look at. And the standard mean difference is much smaller as well. We can look at our p-value here, which is very large, meaning that the likelihood of these 2 things being the same is good. It's pretty likely that our null hypothesis here, that these 2 groups are the same, is pretty likely. So, and then we see the same for the winter term separately here. Those look really similar. So, kind of things that are good to check for, I guess. And then we can do a statistical test. We can do the handy dandy t-test here, the student's t distribution test. And so here we're testing to see if there's a difference between the control and treatment group that we just matched together. And so we get the t statistic here. It shows the degrees of freedom, which are obviously large. So we're, and then we have a p-value that is almost 1. So that is showing that these 2 groups are super similar. We can see the averages here in both the summer and the winter. So matched for the seasons, these are very well matched groups. And then I can talk about that a little bit more in a second. And we're going to clean up we're going to turn this into, we've got our, right now we don't have a row for each observation. We have them side by side. And so we want to make it so that we have a row for every participant with their own matched with back with that billing data. So we have their, the other columns that I had that we've lost. I'm going to scroll down, a little bit of formatting here. So now we can see how many participants we lost. We started out with 5,000 control group members, and I think it was 4,997 treatments, or something like that. So we lost just a few treatments that didn't have a good match, and then we lost some controls, but that's okay. That's pretty normal. I feel like most of the time I'll see control groups that are smaller, and that's no problem because we're going to make sure to preserve, we're going to make sure to weight our billing data appropriately so that all of those control group members that were supposed to be matched to multiple treatments, they'll get, we'll count that billing data multiple times to make sure that that relationship is preserved. That weightedness, I don't think that's a word, but I use it all the time. So moving on to this regression model. Sorry, I should have suppressed that. I don't know what that is. Okay. Are there any questions so far? No.
Can I jump in for some of the audience who might not be familiar with the software you're using? You're using what I use. You're using R.
Yeah, I'm sorry about that. Yes.
Markdown. Tidyverse. I recognize Tidyverse.
Yeah. Yeah, we use R at ADM. I mean, we also use a lot of Excel, but for our programming language, we use R and then I mean Justin deals with a lot of our larger data sets. When we have like 15-minute interval data, he is kind of as far as I know, the SQL servers are at ADM, and so yeah, we use some SQL and things like that, but yeah, R is what we use. I like R. I think, oh, typo. Sorry about that. I like R. I think that it's I mean, it's easy to read and it's easy to, it's easy kind of, but I think that if you're choosing a language to learn, I think that there were some questions for Julia. I think that if like me, you took some CS classes in your schooling, that it might be good to just go straight to Python, because it's not similar to C++, but it's I don't know, it's more, there's more to it, I guess. It's not, I feel like R is just kind of like reading, like it's English. You're just like reading words, especially dplyr. And so I feel like Python it's harder to go back, because I started with Python and then I've gotten so used to R that I go back to Python and I'm just like, you know, I forget that there's just some little things like people will use like periods in their variables in R, but you can't do that in Python because you use the dot operator to use functions and stuff. And there's just different things. There's R is a functional language, and so you can do things like let me find a good example. I don't want to scroll a bunch and make you sick, but you don't change, what is it, passing by reference? Sorry, those terms really trip me up, especially when I'm, you know, all nervous. But anyway, there are some differences, and I think that it's easier to learn Python first, I guess is all I'm trying to say. But they're both useful, but I have gotten used to R and it has really grown on me.
This is Julia. I would totally echo that.
Yeah.
That Python is really easy to learn right off the bat, mainly because I think the language makes more sense to start out with. But then with R, you have kind of certain nuances that you pick up as you learn it. And it is more difficult to go back. And so just based on what I've seen so far, learning Python is a little bit easier. It's kind of like the snowboarding versus skiing method. Like skiing is easier to learn, but harder to master, which is kind of like Python. R is a little bit harder to learn, like snowboarding, but a little bit, you know, easier to master as you get used to it. And so that's kind of how I like to think of the two of them.
Yep. Yeah, I totally agree with that. Yeah. Okay. So this regression model. We're gonna, the linear, the LMER function from the LME4 package is the linear mixed regression model that I use most often. You might be familiar with this sort of equation. It's a mixed effects models equation. So we have our average electricity consumption is what AEC stands for. And then we have these different interactive terms. So these coefficients, these betas, are what we're going to measure in our model is going to spit out basically these coefficients for us. And by the way, you can do this exactly the same as you can in LaTeX, I'm pretty sure, which is pretty handy. Just another reason Markdown's pretty cool. So basically, we're incorporating the fixed and the random effects in our model, because we can't just measure, like I said earlier, you can't just measure that, you know, I used less energy this year, but maybe it was cooler this summer. And so that there might be all of these, you know, all this convolution, all of these reasons that aren't statistically significant reasons for you to have less usage. So we're going to incorporate that random effect. I guess really our random effect here is weather, but we have it split up into that cooling degree day variable and the heating degree day variable. And then in addition to those, we have post is, we call it a dummy variable, meaning like before my little snippets of my data frames showed that everybody is a 0 or a 1 for their post, meaning that if it's before treatment, they have a 0 because it's not post, and a 1 if it's post treatment because it's post. Similarly with treatment, they're a 0 if they're a control, and a 1 if they're in the treatment group, for the same reason, so that this is 0. This post times treatment is 0 because 0 times 0. And so that this coefficient is a 0 as well, obviously. And then we have our customer numbers, so that it is, it's, incorporating the actual participants and their usage. So we're gonna do another statistical check, or whatever the heck I typed there. I have no excuse. Our notebooks actually do have spell check. So we're gonna get our model data back. We're gonna do an inner join with that billing data and our new matched participants list. So we're gonna slim it down a little bit from what it was. I guess we started out, we had our billing data here, and now it's model data. And so just one more check, one more t-test. We're gonna get the pre-data here again, but now we have our average daily consumption variable back. So we're gonna make sure that even if we're ignoring the seasons, if we're ignoring summer and winter, we still have pre-program equivalency, and we do. We have another large p-value here, and you can see that the averages are really close. So that's what we're looking for there. And then we can do a visual check as well. We can use the ggplot package, which a lot of this is just my naming and stuff. It's not really that, it's not too complicated. We're grouping by and summarizing to get the average daily, the average daily consumption for, again, for each of these months here. And this is before treatment. So this is up to May 2019. So you can see that they're really well matched. It looks like the same line. So it's really not that helpful, but it's good to see. And then we can come down here and actually run that regression model now that we know that they're so closely matched to begin with. So here's that lemur function. And then we can see how our average daily consumption correlates with all of these other things, how it interacts with all of these other elements. So we've got that this is the same as that equation that I showed. So we've got our heating degree day, cooling degree day, and all of these interactive terms. We've got our data, and then we're gonna look at the account numbers. So here's the raw output from that lemur model, which shows us pretty much everything that we need to know, but there's oddly, there's more information that summary gives you. So that's why I like to use the summary. And then I also like to take a look at the R squared terms and the p-values, which you might be familiar with. Most of these terms from your statistics classes and things. I really like being able to connect that. I think that when I was even in my math education, when I was expecting to go into data science, I don't know, I couldn't really see the connection. So I like when I can use, when I can look at my mathy terms and be able to, be sure about my results because Dr. Saransev and Vera Ruiz taught me these things. So thanks for that. So anyway, so we can run our summary. I loaded another package called Moomin for this R squared, for the R squared value. But we've got those, and then the summary of the mixed fit. And now we can see all of our T statistics for all of these coefficients, which is another way to show that we have statistically significant results. We can see the correlation, and then we can look here. So this R squared is going to show the correlate, like how closely, how far we are away from that regression line. So 0.65 is not excellent. It's obviously there's some, that shows me it being kind of far away from 1. It shows me that there is some variance in the data, but that's to be expected because it is real data, it's random. And so that's not super concerning. But, you know, ideally, if you had an R-squared value, sorry, these are the marginal and the conditional R-squared values. But that's okay. So we're going to focus on this piece right here. This post-treatment coefficient is what shows the difference, the savings between that post period for the treatment participants. So we're going to focus in on that one right there. We've also got our p-values, which are very small. Okay, so this is the way that I would interpret this. I'd say that we have 0.52 kilowatt hours of energy per day difference. It's negative, so we're showing a negative difference, which is an annual total of about 190 kilowatt hours per person. So recall that our average usage was 8,400 kilowatt hours per year, compared to this 190. So I mean, it's not a huge savings, but we can say that it is statistically significant, because we can look at this t-value from the student's t-test, which I didn't know this. I don't know if you guys do, but the student's t-distribution, it's William Seeley Gossett is behind there. He was the head brewmaster at Guinness, and he would publish all of his statistical research under the pseudonym student, which I just think is kind of cool, because I think that it just reminds us that we should always be learning, like we're always students, and there's a lot of humility, and it's important to have a lot of humility because there is so much to learn. So I think that's pretty cool. I think Gossett was a pretty cool guy. Anyway, so we can compare that with the critical value of 1.645, which is the critical t-value for a large data set, where it looks more like a normal distribution. So the absolute value of this negative 8.11 right here is obviously much larger than 1.645 for my alpha equals 0.1 level that I'm looking at. 90% confidence for a two-sided t-test, because we don't want either end. We're not just looking for greater than or less than. I should have had a picture for that, but anyway, so that's usually what I'll reference as this t-value for statistical significance for this savings value right here. And then in addition, we can do a quick sanity check and make sure that we have, I'm sorry, using a Windows mouse for my Mac. Okay. We can check and make sure that we don't have 0 in this confidence interval, meaning that, again, just to check that our savings are significant. Because if we had 0 in here, it would be difficult to, this is the change, the confidence interval for the change in usage. So it'd be difficult to claim that we have statistical savings if 0 was a likely possibility for that the confidence interval, since the confidence interval is I don't know why this is always such a complicated definition for me, but the likelihood of seeing more extreme, it always makes sense in my head and I can never say it right. But anyway, you guys probably know the definition of a confidence interval. But anyway, the likelihood of seeing a more extreme data is low in this case, low, yeah. Sorry, totally screwing this up. I'm sure you believe that I have a math degree. Anyway, so in conclusion, we can reject the null hypothesis with a good amount of confidence, because of all of these statistical tests, we can show that these are significant results, and that this intervention is a success, that this treatment is a success. So that's pretty much it for that. Does anybody have any questions about the example analysis or or anything else that you want to ask about, working at ADM or data
Yeah,
science.
Could you tell me, like, if they have anywhere in the diagram where it showed you the percentage or whatever, like 52 up here, or, it says post-treatment 52 or 0.52 for the
Mhm.
estimate? Up a little bit lower, you
Sorry.
gotta go down lower.
Want me to go here?
0.52, yeah, right in the middle of the screen, right there, 0.52. How do you equate that to dollars?
Oh, so we're usually estimating usage, so the kWh usage, and I can't recall what like NV Energy's cost per kWh is. I don't know what it is. I could look it up really fast. But we're not usually estimating like dollars saved. We're usually estimating the electricity usage that's saved. And then sometimes, like in a home energy report, for example, it might say, saving such and such amount by, running your dishwasher with a full load might equal a savings of, $12 a year or something like that. But I'm never actually calculating savings in dollars. But this is meant to represent a change since since our value that we put in, that average daily consumption, was in the units of kilowatt hours. That's what this estimate is. It's a negative change of 0.52 kilowatt hours per day per person.
Okay, thank you.
Yeah.
How do the customers of ADM use this information?
So we evaluate these programs we're really a third-party evaluator for utility companies. So they often have a company that we call an implementer. They implement the program, whether that is sending a technician to someone's home to install, weather stripping or pipe wrap or new light bulbs, or the company that develops a home energy report and then mails it to people, So they have a company that implements the program, and then they claim a certain amount of savings from their program. And we often, we are also a consultant, but often what we report on is we verify those savings. And so we do our own independent analysis, and we take all the information from that implementer and from the utility, and we do our independent analysis, and we determine if we agree with the savings that they're claiming, basically. So we will report this information in a really long-winded, wordy report, and interpret the results for our clients, and then we'll offer different recommendations to increase that savings for, in a fiscally efficient way, and things like that, things of that nature.
Do the clients provide all the data sets, or do you also have to go out to other data sources?
We usually, like, this billing data was provided from the utility. It usually comes from them. Sometimes it comes straight from the implementer, which is kind of nice because then we know that we're looking at the same thing. We do some surveying. So my sorry. So when we survey, that's usually part of the reporting process. And that survey might include a lot of things about, like, satisfaction for the utility, or how did they hear about the program, or have they replaced light bulbs, in addition to, did the program they participated in, that inspire them to do other things. We call that uplift. But we also might include things about, did you leave the measures installed, or did you do these other things? So we do use our surveying effort as some extra information. But as far as billing data goes, that's something that is always provided to us. So most of the things we get, the participants and things like that. But there is some other information that we gather through surveys.
I have a question queued up from the chat, but before we do that, it's kind of a big picture question. Does anyone have any specific questions about the example that Lissa showed?
This is Julia. So Lissa, just because there's a bunch of students on the line, I know we use students t-test all the time to compare, different groups together. How often do you guys use this particular test? And do you recommend having this as like your base, really good understanding of, like, what am I trying to say here? Like having this in your back pocket for a lot of your analyses, how important is it for students to really understand how this works and what the different assumptions are?
I think it's really important because I use it all the time, sometimes just quickly to see if, just as like a preliminary data check, like if our two sample sizes are equivalent yet, or if like we have a much larger treatment group than control group, like we do in this case. When we sample, we have to make sure that we've, collected a significant amount that's proportional. So like in Excel, I use the prop test a lot. But in ARIA, I'll grab this t-test a lot. But I think that it is important to understand the math and to like remember how things work, especially with the regression models. Like anybody can Google how to use a regression model, but like I think that it's important to understand the math that's going on behind it. Yeah, I think it's important. I think it's also important that you have to understand like those statistical terms, because I mean you can look and see that the averages are close, but I think if anything that this last year has taught us is that like critical thinking is really important, as well as like what does the data mean? What does the answers that the data can give us mean? And I don't know if that answers your question, but I think it is important to like remember that the definition of this confidence interval that you're claiming, or like what does this p-value mean? What is it proving? We don't just like spit the t statistics. I probably didn't do a very good job of explaining, but we don't just spit like mathematical jargon at our clients. That doesn't mean anything to them. So we have to kind of explain well why we can defend our results based on these specific values because of what it means, I guess, under the hood.
Absolutely. And I think you hit the nail on the head there, where it's so important to be able to understand the math behind it, because if you just give somebody a p-value but you don't understand what that p-value means, or if you can explain it without the p-value, that's my favorite thing with my MDs is they'll ask for a p-value over and over again, and it's like, well, there are other metrics we can use to show you that this is impactful. And so having those skills to be able to identify these different metrics basically to show that this is a very good model is really important.
And a lot of things it's not black and white. It's not concrete. Like if you have a really, really small p-value, like, yeah, you want to say that they're different, but really that means that either the null hypothesis that there is no difference is true, but we've seen a really rare event, or the null hypothesis is false. It doesn't, most of these statistics aren't like a yes or no. You want to look at like sample sizes and different things. I think that you kind of have to look at it like a whole. It's not the p-value itself isn't like your yes or no answer. I think that it's good to kind of understand the bigger picture of how all of those math terms kind of fit in. And I think that it is beneficial to like have a deeper understanding of the math, even though I don't use like pen and paper statistics every day. I think it's been helpful. There was a little bit of like a learning curve when I first started, and like connecting those terms from pen and paper math to being able to discuss it with my boss about, why I think these results are significant or whatever. There was a little bit of a curve, but once I got over that and started to see the connection, I could see how beneficial that background was. Yeah.
Any other questions on the case study that Lissa has presented?
I just have one question about the p-value. When you're looking at the p-value, I noticed that the p-value was on one of your examples was was 0.9 or something, but you're looking, I know that the 0.9, you're looking at that as if they're very similar. They're not different, so they're very comparable, right?
Yes.
So
Yeah.
when would you use the 0.05?
I'm using a 0.1 here because of the, I'm using it like a two-tail, I'm just looking at the middle. I'm using a two-tailed t-test in this case. So that alpha level of the 0.1 is, I'm sorry, that's not what you're asking. But yeah, so 0.1 is the critical value that I'm looking at, is the alpha level that I'm looking at. And I'm using that to determine if there's a difference. So like here, what I have on the screen right now, this post times treatment coefficient here. This is the p-value here, so it's super small, which is indicating that it's possible that they are different. That the assumption that they're the same is probably false because this is so small. So if this is what I'm looking at to be under 0.1 right
Means
here.
that there's a really huge statistical difference there.
Yeah.
Thank you.
Yeah.
I was confused. I thought you were using 0.5 and you're using 0.1, so that's, or 0.05 and you're using 0.1, so it's.
Yeah.
makes more sense.
It is
Definitely.
the same critical value, that 1.645 as the Z value is the same because I'm using a two-tailed test. So that 1.645 is numbers always in my back pocket to compare to the T value anyway. I mean, but yeah,
Yeah, thank you. Appreciate it.
So we can cycle back and talk more about the analysis, but I'm going to start going into some of the more bigger picture questions. So in our chat, Jeanette asks, even though I am an IS major, I haven't learned any computer languages yet, and I was wondering if you recommend to learn Python for data science the most.
I think that Python is, and Chris and Justin and Alex should probably weigh in as well, but I think Python's more versatile. Like you can do a lot with it, and I think there's a lot of companies that are more open to using it. Yeah, I think it's also useful to learn to get comfortable with command line and Git for like code version control and stuff, and then you have something to show to like potential employers and stuff if you have like personal projects, if you've done like a Kaggle project or like or a whole thing on data camp or something. If you keep all your code in one place, it's just good to get comfortable with that because Git is sort of a weird black box thing when you're not used to it, and it's good to kind of get comfortable with that. But yeah, I'll stop. Does anybody else want to weigh in on the programming languages?
Yeah, I think there are several reports that have come out. People do surveys on basically job listings on what the most commonly listed programming language is for data science positions. And Python is pretty consistently the top, with R a pretty close second. So if you're going for general skills, I'd say Python is probably the best starting point.
Yeah, I would agree. Python is great to start with, and it can do data science, but it can also do a lot more than that. That said, I wouldn't stress a whole lot on the language. Like, I think either Python and R is good, and you'll find that if you learn one and you have to go to the other, just Googling how to do this Python thing in R or how to do this R thing in Python, there will be like a million results on everything that you search for because there's so many people transitioning between those two languages. So I would agree that Python's a good one to start with, but once you get one under your belt, it's not going to be nearly as hard to learn the second one. So don't stress too much about it, I would say.
Yeah, I totally agree with that. There's actually a lot of packages that help you to like write Python code into an R notebook like I did and stuff like that. There's more of that. But also, yeah, I think when you're fluent in one language, I think it's beneficial to immerse yourself in one language, whether you did learn C++ really well in school, like I did not, or not. Just to be immersed in one language is super helpful, because then you think in code, like you're thinking in pseudocode, you're thinking algorithmically. And so you can say, how do I do this in Python? And yeah, you'll have pages of Google results, and you're just going to think about it, right? Rather than just kind of like, you know, fumbling around, trying to figure out how to even do what you even are trying to do, you know, but learning one language at least to start is super helpful.
Lissa, I think you made another comment that I want to echo, which is your comment about Git. And actually, so GitHub is a place where you can publicly share your code, for instance, if you're a student, and basically show potential employers your work. And that could be quite valuable. That was something that didn't exist when I was a graduate student.
Yeah, yeah, and even just there are certain packages, like for R, the general repository is called CRAN, where you can just type install packages into your R terminal and install it. But there are a lot of like code that you know, Justin and Chris write at work, and if I'm using it, I can download their package from GitLab. And so if you're comfortable like with using a command line terminal, you know, using a command line terminal to do it, and it just makes your life a lot easier if it's not not so scary. But yeah, GitHub or GitLab, they're the same, but the language is the same as far as I know, in order to get your code there and pull it back out to, you know, push your code. But yeah, a lot of times, like your Google searches will lead you to somebody's GitHub repository, and so you can kind of get familiar with the jargon that they use, I guess. We use GitLab at work for all of our stuff. So it's like it's a private repository, so we can only see it if we're on our work server. But that's a good way to share code for sure.
I'm going to jump in here and just add that it's a really wonderful way to show future employers that you understand version control, you understand how to back up your work, and you can work as a team member. So, you know, our business model at ADM, we work in kind of little pods, I think, more frequently than we work in like a large scale data science development team. But if you're working with a team of folks and you are all developing code simultaneously, having skills in your back pocket, like how to use Git, will be crucial. And so that is a super simple skill to pick up just by, you know, hanging out on the internet, Googling a little bit and trying it out with your own code in kind of like a low stakes scenario, you know, figuring out how it works. And then you're able to, sorry, my dog is squeaking on a toy back here. But it's a great skill to have, and really, I think, adds a lot of value to you as a future employee.
On that note, I would also mention, if anybody was looking to get into the data science field, probably the best way to kind of boost your resume in a pretty low effort way is to have your own GitHub page, have a link on it on your resume, and also have data science projects on that GitHub page that employers can look at and get an idea of your skill level and experience.
Yeah.
I was just going to tag on to you, Chris, comment your code. That's,
Oh,
I think,
yeah.
you know, so we definitely at ADM like look at code samples when folks are getting hired on as data scientists, and imagine just like pulling up you know, whole nest of functions that you've never interacted with and you don't have any context for, but you're like, all right, I'm checking out someone's code that they've shared as a sample without a ton of comments in there. It's gonna just be a nightmare for anyone on the interviewing side to read through it and get a sense of how you work and how your brain thinks through problems. So I'll just say, add some comments in there, explain it. You'll do yourself a favor in the long run, because 2 years from now, when you go back to that code, you'll understand it in a pinch.
Oh.
But it's a great practice to get into. We do that a lot internally because we share functions a lot. So, Lissa might borrow a function from Chris's code to try it out with her data set this year. And there's a lot of that sharing back and forth. And without comments, it would just sort of be a tangled mess for everyone and pretty inefficient to sort everything out and kind of plug and play. So that's another good skill you can really easily work on just, in little projects in class, is just commenting what you're doing. And I'm sure any faculty member on this call would be glad to see you comment your work as well.
So that brings up another question. So I worked for a company once where there was a lot of turnover, and so code was maintained across different people. How do you guys at ADM cope with that, if you do?
In my experience, our code could have been commented better. The code that I inherited could have been commented better, for sure. It also wasn't, at least I didn't get it from GitHub, because at least if it's like, if you're, you've got commit messages, like every time you make a commit and you push your code to GitLab, in our case, there's a message for maybe what changed or whatever, and you have a README there ready to go to kind of explain this code's use. And it hasn't been great, but like Alex said, there's reasons why we all, it doesn't take very long to figure out how useful, how helpful a lot of comments are, because instead of trying to, you can read the words to get an idea of how it works, rather than having to like run every function and really, figure it out.
So students, what are your questions?
I have a question as far as what can you do in the meantime to, like, if I'm in the PhD program for public health and I'm trying to maybe pursue a job in data science, and I'm not sure exactly how I can beef up my resume other than creating my webpage that you just mentioned, or the hub, and I'm just trying to figure out like what's the process of applying, and what kind of skills should you have before you even apply, that type of stuff.
Speaking as someone else who left a PhD to go to the non-academic world, I think one thing that you could practice doing is figuring out how to describe your PhD work to people who have no background in what you are doing your dissertation in, and figuring out how to extract skills from your research. So, for example, let's see, for me, I studied the decay of radioactive isotopes, which you would not think is applicable at all to economics or energy. However, diffusion of, different radioactive isotopes and their daughter products is the same mathematics as the diffusion of product adoption in a marketplace. So being able to do enough legwork in the fields of the companies you're interested in working for, figuring out what kind of like root skills that you have that can be transferred. So understanding mathematics, understanding statistics, or maybe teaching, if you're teaching in a academic setting, you are communicating information to people effectively. You are learning how to put together presentations. You're learning how to write, all of those skills, taking those and starting to boil down for yourself how those transfer into like a job setting. Like, how is that a job skill that I could bring to the table for the team at whatever company I'm looking for? I think that is sort of the weirdest perspective flip that you have to get a handle on when you're trying to leave academia and take all of these great skills that you've developed. And sometimes it can be difficult to repackage them in a way that someone at a company reading through resumes says like, oh yeah, that's a skill I need. Because I think in academia, we sort of can get lost in our own our own bubble and forget about exactly what is at the heart of all of the skills that we're learning there. I think that's another kind of low bar to entry thing that you can sort of mull on over time and start working out in how you explain that in a resume, and it can be really helpful.
You know, one thing that they always emphasize to us in everything in school is that you just can't have schooling. You have to have experience too. And it's like, how do you get the experience when all the companies want you to have experience before you get in there? And it's like, you know, it's like you can't just count just school as experience a lot of times.
So I think it depends a lot on your employer. I think some employers will understand what the experience of spending 5 or 6 years getting a PhD means, or spending a couple of years getting a master's degree, like what that experience means. But I think going back to what I said earlier, understanding how to pivot what you're doing in graduate school to being an applicable skill. So for example, I had a year of consulting experience before I went to graduate school, but I didn't have, you know, a full resume of several years of consulting experience when I came to ADM. But what I did do a form of consulting. I was consulting with other research groups that came to my lab to work with me and to work with our research group and use our mass spectrometers. It's a different kind of consulting, but we still had clients. So that's what I'm saying is you gotta like really invert all of your thinking about what you're doing in your lab groups and in your research teams at school, and pivot that into something that sounds a lot more like real world experience, because it really is at the heart of it.
Most of the time we're just trying to shoot for like these temporary jobs where they probably would be more lenient on hiring people to train them. You know, it's just like whatever experience we can get, you know, but.
So I think another thing to look at a lot is you can find the companies that value and understand a diverse skill set and a diverse background by just doing a lot of LinkedIn stalking, to be honest. Like get on LinkedIn. If there's a job that you're interested in, go on LinkedIn and look at every single person in that office or at that company's background and see what they are. If everyone at the company has like a whole list of credentials that they were like, I studied microbiology and then I worked doing microbiology and then all I thought about was microbiology, and everyone at the company looks like that, it's probably going to be really hard to not come in with experience in microbiology and help them. But if you are looking at a company, you know, this is part of why I got excited about ADM, like Lissa, Chris, Justin, and I don't think any of us took classes or like had degrees in like energy efficiency, for example, right? We had a really diverse set of skills coming in and we had a foundation. But then, you know, we could all see that everyone else sitting at the table at ADM, there are economists and there are engineers, but there's a really diverse group of folks working there. So I think, you know, you have to market yourself, but you also have to find the right audience. And that can be tricky, but it's not impossible.
I know I love energy efficiency. That's why I think this job would be better suited for me, because I might find happiness because, I mean, I go with the most energy efficient air conditioner for my house as 20 SEER that they sold at the time. I have 2 electric Teslas. I mean, everything energy efficient. I go with my pool pump is a variable speed. Everything I invest in is energy efficiency. And so I just, I think energy efficiency is something I'm really attuned to. So I look forward to maybe doing it.
There's another trick for those of you who are in school, and that is to do a summer internship. And when I was in grad school, I did 2 summer internships when I was in school. My advisor was generous enough to let me go. And so ADM folks, do you take interns?
We do occasionally take interns. I don't know that we've taken too many data science interns in recent history. Most of our interns, I believe, are on the engineering side of things.
Yeah, I had the opportunity to do some research with Dr. Andrei Sarantsev my last semester of school. So we were working on some market trends research. So I think that was kind of probably the most relevant, outside of a personal project sort of thing that I had. I thought that was a really good opportunity. And then I think, and like Julia mentioned, getting her data science certification on Data Camp, I think like the whole project sort of thing, like start to finish, is something that you can have on your GitHub, on your GitLab for sure. And then also just the experience of like starting from scratch and getting somewhere. Whereas like when you do the quick little like puzzle sort of things, like your daily like Python puzzle or whatever, like it's hard, at least for me, to connect that to starting on an empty project or whatever. But like starting from scratch on a Kaggle project or something else where it is a whole certification or a specialization, that's something that I think is indicative of like what I just did. Like anybody, like any of you could do that. You could find a random data set there, especially in R. There are a lot of built-in data sets like diamonds and empty cards. You see them all the time in the Stack Overflow examples, but you can pull that kind of data and you can make your own assumption, your own hypothesis, and you can do something like this. And basically that's my job. And you can have that on your GitHub as an example that you're aware of how to think through a problem and decide if your answer makes sense, and how to formulate a question and answer it using data. And I think to answer, I found the chat finally, but Jeanette said she was in the hospitality industry, and now she's in the IS field. And I quit school for a while, and I did a lot of different kinds of jobs before I came back. And so I had that like work experience, but not relevant work experience, which I think is also helpful because it shows you can work with other people. But so does getting, I'm sure, the years that you spent, Alex and Julia, getting your PhDs, like you're working with people, you're doing research, working with a team of people. And so I think there are a lot of elements, like Alex said, that you can connect.
Not to make you uncomfortable, Lissa, but you had a ton of great work experience that was like, I know as somebody who's on the other side of the table when you got hired, that was really wonderful for us, especially consulting companies, like any kind of work experience where you have customer service skills, you have communication skills, you have management skills, especially of other people. That's so invaluable. So don't sell yourself short if you're like, oh man, like all I was doing was, I don't know, working like a retail management job for a couple of years. Like that is amazing experience. So like, again, pull out all of those skills from that job and really lean into them, because I know, like looking at Lissa's experience, she had the mathematical background, she was motivated, and she had a lot of great personal experience and work experience that we knew she could be someone who'd come in and take the job seriously and work hard. And she's definitely done that and been a really dedicated, awesome member of our team. Gotta sing a bit.
I was going to say that there's another question on the chat. Christian asked, to piggyback off the last question, are there any certification routes that you would recommend to beef up your resume?
I could probably answer that as somebody who's taken a lot of, data camp and online courses for data science. I don't know that there are any specific certifications that you can acquire, but definitely listing those classes, online courses for data science is good. But more than that, I think data science employers are more interested in the projects that you've done that use data science rather than the classes you've taken or the certifications you have. So as long as you have projects that prove that you've worked with a certain machine learning algorithm before, your employer is going to be more comfortable knowing that and being able to see that in your GitHub page. And so speaking to one of Lissa's points about available data sets, Another good resource for that is Kaggle, where they host a bunch of data science competitions and also have freely available data that you can use for, your own project or any other sort of application you can think of when you're working through all of those data sets.
Yeah, I would 100% echo what Chris just said. When I was working as a software engineer and I wanted to transition into data science, I did the Udacity, they call them nano degrees in machine learning, which took about 6 months, and it was kind of expensive, honestly. I don't think anybody cared, honestly, about the classes. At least they didn't care what I learned about like supervised learning or what algorithms I use. What they did care about was the project at the end, because at the end of that course you would do a project and you would find your own data set and you would implement whatever algorithm you thought best and come to your own conclusions. And that I talked about that a lot, both when I tried to transition within Dillard's to data science, and also when I applied to ADM. That was super helpful. And so I would agree, the classes are nice, especially if you need some more background in maybe the programming languages or algorithms or whatever. But at the end of the day, like if you can talk about a project and just talk about like how you thought it through, even if you made mistakes throughout it, I think employers want to see that, because it kind of gives them an idea of like how you think through things and that you have some experience. But
I will say, I think there's kind of a interesting paradigm shift that a lot of folks have to go through when they leave an academic setting into the like applied setting at a consulting firm or at any company. And one of the biggest skills that you can figure out in your time getting educated is the skill of learning, being able to get stuck and go figure out the problem. I think this is a lot of why, what Chris and Justin are saying, like it's way more valuable to have a problem that you've worked through, that you've had a result that you've wrapped up. To be able to show and demonstrate that you can do that is so much more valuable, because you could take every single class and sit through all of them, but without being able to demonstrate your ability to hit problems, work through problems, and reach a result, it's kind of scary to an employer to bring you on, because nobody at your company, well, depending on what company you join, ADM is definitely a sink or swim type of organization, but most companies, there will not be people who are there designed to teach you, coach you, and make sure you get taught the way you're taught in school. But there will be people there who want to know the answers and outcomes and what your roadblocks were and how you figured those out and resolved them. And that's how you contribute to a team, and that's what adds value to a company. So being able to have these projects that you can talk through and explain how your mind worked through a problem and how you resolved the issue, that's really exciting and valuable to, I don't know, I guess I can't say every single employer, because I've never interviewed or worked for every single employer, but to almost everyone, that will be super valuable.
I can reinforce that, because when I did look for jobs after my degree, the job interviews, all we talked about were my summer intern projects. There was very little discussion of my research in grad school, my classes. A lot of it was about the projects I did as an intern. More questions from students, please.
That's more like a comment. I wish ADM would offer a course that would teach students everything they want them to learn. They'd be better prepared, and it would look really good on the resume.
I feel like this is a little bit different subject, but I guess on what like Alex said is, I think the most valuable thing I learned from my math degree was I honestly feel like I can do anything now. That was the hardest thing. I don't know how many of you are math majors, but oh my gosh, like anytime I'm like almost in tears because I can't get code to run, like I just realized that like I can do anything that I I can figure anything out. Like and the amount of like, it's just the amount of time and effort, like I feel like I can do anything because I got through that. So I must be able to, you know, with Google's help, figure out how to run this. Yeah, I feel like that is, I didn't understand before I finished my degree, but I understand now how valuable like education is. And I'm sure even more so with advanced degrees. And I think just like my point about Gossett is like this, how we called him, he went under the pseudonym student. Like, I mean, I think that it's evident that so many data scientists are always learning because of all these advanced degrees. Like Alex is my boss. My previous boss had her SCD in public health, and Julia from last month. Like, I think that that's a common theme, I think, in people that are drawn to data science or people that are drawn to like keep learning.
All right, we're like 17 minutes past the scheduled end, but I want to give students a chance to ask more questions if our speakers are willing to hang around for a few more minutes.
Yeah, sure. And if anybody has any questions after and wants to email us, that would be good too.
Here's a question. Are you all hiring data scientists these days?
Alex may have a better idea of that. I think with the pandemic, our hiring has slowed down a bit. And we're definitely looking for people with both data science and program management skills. But yeah.
Yeah, so I guess I'll answer this question ADM centric, but then also more holistically as well. So ADM currently isn't hiring. We're sort of in between some contracts. We may or may not be hiring in the next 6 months. So I would definitely, you know, if everything Lissa was talking about sounds really interesting to you, or you're curious to learn more, check out our website, keep an eye on the career tab, and definitely reach out to any of us, and, you know, through that portal, if you see something posted that you're curious about. But I would also say that a lot of companies are always looking for talent, and ADM is definitely in this bucket, or I guess type of company. So I think others probably are different or have different experience. I've never gotten a job or a position in graduate school or anything without having networked into that position or getting information about it. So I cannot encourage you enough to, you know you want to stay in Reno, start figuring out what companies do interesting work that you think is cool in Reno, and just start talking to people. It is awkward as hell, especially if you're a more introverted type of person, but making connections with people, you know, reaching out to them, learning more about their company, learning about their career trajectory and what sort of skills and experience they think is really helpful and pivotal to be in their line of work. That's always great. And then if there is a job, so if suddenly ADM is hiring, but you've been in touch with Lissa, and you've been in touch with Chris, and you've been in touch with me, and you know about ADM, and you see a job posting, you can come to us more quickly because you're, you know, have a pulse on it. But also, if we know you and we know you're looking and we've talked to you and have a relationship with you, we are way more likely to give you a call and say, you know, hey, so-and-so, we actually do have a job opening. Do you want to come in and interview? So I can't stress enough, just like making connections with people, human interaction, get as many mentors as you can. And definitely, you know, as Chris said, if you have follow-up questions or want to know more about ADM, feel free to reach out to us and talk to us more, because it's those connections and that network that you build and can build even as a freshman in college that is going to get you a job way more easily than just blindly sending resumes to any job you see on Indeed.
Yeah, Reno is a really small town. If you haven't been here long enough to notice it, or like Chris, like we met at a data science meetup like a year ago at Shim's. So I don't know. Reno's a pretty small town. And yeah, relationships are valuable for sure.
So I was going to suggest students who might want to follow up with you all can find you on LinkedIn. Would that be okay? And they have your names on the flyer that advertise this event, so they can look you up in LinkedIn and connect with you, if you don't mind.
Not at
How many data scientists do you have at ADM? Is this the whole group?
Not the whole group, far from it. I think, well, we have multiple offices both here and in Sacramento. I think there's also a smaller Fremont office, and each office probably has around 10 or so data scientists or engineers who might dabble in data science. So it's a pretty big mix.
Yeah, we have a monthly data science meeting. What do you think? 10 or 12 people usually end up kind of joining in?
Yeah, those who
Yeah.
aren't busy and can
Yeah.
join us during the meeting, yeah.
Students, what else do you want to know?
I would like to know, like, are you guys currently working from home or are you working in the office?
Yeah, we've been home for a year now. Just a little over a year.
So if we did an internship with you, would we have to go to Reno for that? An internship, how have you done internships in the past?
So we have always been an in-person company, and I think as tides turn, hopefully with the pandemic, I think we're going to be transitioning a lot more back to being an in-person company. So I don't think we've had anyone actually be an intern while we've been working from home in the last year. It's been sort of a weird, uncertain time for the company. I think just, trying to figure out exactly what all working from home would mean and how our contracts would be impacted through the pandemic. So I would imagine that it would be a somewhat safe assumption that we won't take an intern until we're back in the office, just because I honestly think you would get less of a good experience as an intern working from home. I think, you can read any varietal of research you want about working from home or working in the office, but especially for something like an internship where learning from as many people in that setting as you can is sort of the best thing you could do in that experience, learning from them, working with them and developing projects with them. I think it would be really difficult to facilitate that kind of wonderful experience for you with everyone working from home.
Okay.
Yeah, but one day we might go back.
Yeah, just have to, well, I mean, the vaccines are being rolled out to everybody now, so it shouldn't be very long at all.
Yeah.
Yeah.
I mean, I got called back to my previous job as a table games dealer at the Bellagio, so I'm actually, it's a very good job. I love the job. Good money.
Yeah.
Just not something I want to do for the rest of my life. I'd rather do something more with the degree, so. Even if I have to educate and be a teacher, that would still be fun. But me, it's hard being a dealer. The hardest part about being a dealer is standing in one spot and waiting for someone to come to you. I'm very active and I like to be doing stuff constantly, every single moment, every single minute. I do not like to rest. And being a dealer, even though it pays good and I like the customer service part of it, it's hard because you're standing there sometimes with nothing to do, and it's just not me. I have to have things to do. I like to stay busy too much.
Well, that's the thing about being an applied statistician, at least throughout my career, my day is crammed constantly. And it's just pretty intense. And especially in the private sector, there's no shortage of data. I think one of the reasons I didn't choose to go into academia, you have to find a collaborator to get data. in the private sector and government where I am now, there's too much data. Anyone else?
Yeah, I would say the questions you should ask like your employer. This was advice that I got before when I was graduating, was just that you know, find out if there'll be people to learn from at your job. Like Alex said, nobody's going to sit you down and like give you a lesson like your stats professors might be able to, or anybody else. You know, you're not going to have office hours or whatever because people have their own work to do. But you know, you might inquire about how you know, the company is structured. Where are you going to have support? Are you going to have you know, some code to walk into, or like are you going to be left to on your own? Just you know, like maybe not just ask about like opportunity for advancement, but opportunity for like growth and change and improvement in that company, as you know, as well as like positional advancement. But that was some advice that I got, is that sometimes for your first data science job, it can be beneficial to be at a larger company where there is somebody there, rather than like, you know, a startup or something where you're kind of like, you know, data science, right? Like, here you go. Like, if you're the only one, you're not, I don't know, you might have bad habits. You're gonna be on your own. But depending on how you learn best, that could be something that you might want to look at for, you know, how you're going to learn best in the field. Like ask about what their culture and the communication is like. You know, do they have a team of data scientists? How do they communicate? Is there a lot of collaboration? Those are some questions that you can ask if you're interested. Try to get a feel for what it'll be like there, what the culture will be like there.
Absolutely. Okay. Let's see, anyone else? Question? If not, maybe it's time to wrap it up. Well, thank you so much, Lissa and colleagues at ADM. Excellent discussion. Very nice peek into the real world for many of us. And we're really grateful to you for presenting today and being willing to be reached out to by our student audience. And so thank you so much. We'll try to have this video posted, a recording posted pretty soon. And a reminder, we're going to have another symposium end of April, will be probably the last week of April, our third for this semester. So thanks everyone for joining us, and thank you, Lissa and ADM colleagues. You've done a great service for your state by being with us today. Thanks.